Hi guys, Mr. Rohit here. We're going to be looking at Chapter 8 for Year 7 Maths. Alright, cool. So this is actually one of my favourite parts of maths because we're looking at statistics and probability. So the reason I love statistics so much is because it's used extensively in science. Why do we use it in science so much? Because science is about trying to understand the world around us, and to do that we have to gather evidence. And the best way to convince people that your hypothesis is true or untrue is by using evidence to back that up, and that evidence is statistics. Alright, so this is a really, really important type of maths in the real world. Okay, so there is the tale of Florence Nightingale in your textbook, where she transformed the hospital system using data. There's also a more modern one, and Australian actually, with a scientist by the name of Robin Warren, actually found out that stomach ulcers weren't caused by stress, but they were actually caused by a bacterium called Helicobacter pylori, which was actually causing the infection. And so to sort of put everyone's perspective, to change everyone's perspective, he had to present evidence and data and show how people with Helicobacter pylori infections were developing those stomach ulcers, and it wasn't just people who were stressed. Okay, so that's an example of when it's really, really important. So, 8A. Let me take my little camo mask off. I hope you guys like that one. 8A. Now, this has got a lot of notes on it, but they are important. So the first thing we're going to go through is a variable. Okay, so what is a variable? Now, we should know this one from maths. Not maths, but in maths, science. Okay, so a variable is something measurable or observable that is expected to change over time or between individual observations. It can be numerical or categorical. Okay, so that's a bit new. Okay, so something measurable or observable. I'm going to leave it at that actually. Let's just go with that. Something measurable or observable. So let's go into our numerical. Actually, let's make this neat. Okay, so numerical. Okay, so variables, remember, it's something we're measuring or observing, and when we gather that data, the data can be either numerical data or categorical data. Okay, so numerical data is also then broken up into two different ones. But before we discuss that, we're just going to say, so numerical data is numbers. Okay, numeracy, numbers, numerical. Awesome. So now there are two types of numerical data. So we can have discrete numerical, and we can have continuous numerical. Alright, let's unpack this a bit. So we know numerical data is numbers. So if I wanted to ask all the science teachers how many marshmallows they can fit in their mouth, this is important research, okay, we're looking at a number, so it's definitely numerical. Okay, now we have to decide whether it's discrete or it's continuous. So discrete numerical data means that the data must be full numbers. Okay, it must be whole numbers. Must be whole numbers. Okay, make sure you're writing all this down with me too. This one. So the continuous can be decimal places. Okay? Okay, so what I'm saying is discrete numerical can be 1, 2, 3, 4, 5, etc. Whereas continuous can be 1, can be 2, could also be 2.5 or 2.7 or 2.3. Okay, so it's in between. That might not make too much sense now, but let's think about our marshmallow example. How many marshmallows do you think the science stuff can fit in their mouth each? I, for one, can fit probably, I'd say 10, all right? But you might at home think, when you try it, you might think, oh, well, I can fit about 10 and a half, okay? Because you can cut a marshmallow in half. So, 10 and a half is also known as 10.5. So, which one of these two is that? Okay, so if you pause the video, have a guess. So, we're actually looking at continuous numerical data for that one because we can go into those decimal places range. Now let's have a think of something that is discrete. So a good question is, how many pets do you have? Okay, you can have 1 pet, you can have 2 pets, you can have 3 pets, you can have 4 pets, you can have 20 pets, maybe you have a fish tank. Okay, but you cannot have 2.5 pets or 3.4 pets. Okay, so that data is discrete. Okay, because you can't actually have a decimal place or a half of a cat, right? Alright, it won't be a very happy cat. Alright, so that's our numerical data. Now, let's have a look at categorical data. So, categorical is non-numerical. And I want you to think sort of back to science. When have we compared number versus non-number observations? Was it? Have a think. If you thought of quantitative and qualitative, well done, because that's exactly what we talk about in science. Okay? So reward yourself, go get a biscuit, I don't know, pat yourself on the back, alright? Because you did good. Alright, if you didn't get it, that's alright. Just remember trying to link those two things. So categorical data is non-numerical or data that is sorted into categories. Now, doesn't that make a whole bunch of sense? Categorical categories. How good is that? Alright, so think of an example of categorical data. I've got one. Okay, an example of categorical data. What type of car, or what brand of car you have at home. Okay, so for that you might have Mitsubishi, you might have Ford, you might have Hyundai, Kia, here we go on for a while, okay? So those are categories, they're not actually numbers. But if I asked how many cars do you have at home, now we're talking about numerical data, okay? So categorical, we're talking about categories, non-numbers, okay? So what type of? Alright. Another one could be what type of pet do you have, going back to the last example. Okay, so that's changed it to a categorical question instead of a numerical question. Alright. So you've probably done this before, categorical, when you're doing a survey and it says 1 is disagree and 1 is agree. Okay, because what you're doing is actually sorting your preference for things based into a category. So that is categorical data. So I want you to now pause the video and come up with your own examples for each one of these. Alrighty, let's move on. Like I said, a lot of notes today, unfortunately, but that's alright. So, now we're talking about sources. Now, I'm not talking about tomato or soy or hoisin or mayonnaise or sriracha or sriracha mayo. Not talking about any of those, right? We're talking about where we get our data from. Alright? So we've got primary sources and secondary sources. So think about the words primary and secondary. Where do you source your information from? So primary source, remember primary is sort of like first, right? So it's first-hand information that is collected from the original source, okay, or person or organisation or whatever's going on. Okay, secondary sources have actually already been summarised by someone. Okay, so primary sources, first-hand data, or I would call it sort of raw data. that has been collected. So if I asked all the teachers how many marshmallows fit inside their mouth, okay, and I went around and got all that data myself, that's a primary source because I've gone to each of them and I've seen them do the experiment and I've written down data, that's primary. Now if I go and give that to Mr. Lamb, for example, and he starts reading it, that's now, if I collate it, make graphs, interpret that data a bit more, then that's going to be a secondary source for Mr. Lamb because he's just receiving that data. Okay, so collated data that has been interpreted. Okay, so ideally we want primary because that is the most accurate. Alright, so next bit of terminology you're going to get into. Pause it, make sure you've got that written down because I'm getting rid of it now. If you don't like the way I sort of worded it, that's fine too. You can always check your textbook. Remember the blue box. Alright. So last bit of definitions today. So we're going to go through 3 keywords: census, sample, and observation. Okay, so what are these 3 things? Census, a sample, and an observation. Okay, census. This is where the whole population that you're looking at is asked. Okay, we gather data on entire population. So if I'm asking all the teachers in Moana how many marshmallows will fit in your mouth, that would be all teachers. That means Miss Laidlaw, Mr. McMillan, Mr. Jard, Mr. Wetherill, everybody. Okay, everybody. Now, sample is where we gather data from a select group randomly. Okay, so these we just randomly pick certain people, so there's no selection there, it's just a purely random choice. Okay, and that gives us sort of an idea because we can't always do a census of every single person in the population, or if we were looking at magpie size, we would have to catch every single magpie in Australia, and obviously that is not really useful, possible really, so we have to do a sample of randomly grabbed ones. Okay, last one is our observations. So observations are where we gather data still, but from non-random populations. Okay, so sample was not the whole population, but they were still random. Okay, so that's good. Observation is where we're sort of just seeing who's there. So it's not random. The example the book gives, which is really good, is actually sort of like people posting their opinions on a website. Okay, so because they're posting opinions on a website, it's not random. If we were going to judge their opinions, if we were going to take that data, it's not random because they've self-elected to say their opinion, and we're not collecting those people who, might not have written their opinion but still have it. Okay, so that's not a sample, it's actually an observation. And the science teacher in me needs to add this. We're sort of going down in accuracy. Okay, so if we can do a census, that's the best thing to do. Can't do a census, then we can revert to a sample, which is also still pretty good. And if we can't do that, we can do an observation. Alright, cool guys. Hope you've enjoyed the video and good luck with 8A.